The atomic radius of an element determined by two factors, which is effective nuclear charge, Z effective, and shielding effect. Effective nuclear charge, Z effective, is the net positive charge experienced by valence electron. The formula of Z effective is Z minus S, which is the Z is number of proton and the S is the number of electron filled at the inner shell. When Z effective increases, the nucleus attraction toward electron becomes stronger. The nucleus pulls the outer electron closer. The atomic radius becomes smaller. Example 1. Explain why size of atom 17 chlorine is smaller than 12 magnesium. The atomic radius of chlorine is smaller because the nucleus pulls the outer electron closer with a charge of positive 7. The atomic radius of magnesium is bigger than chlorine because the nucleus can only pull the outer electron closer with a charge of positive 2. Generally, shielding effect proportional atomic radius. Shielding effect. The shielding effect is caused by the mutual repulsion between electron of inner shell and the electron occupying valence shell, also known as the screening effect. It also occurs between electrons in the same shell but is less effective compared to that of electrons in the different shell. So, more the shielding, more the outer electrons are shielded. The attractive pull by the nucleus on the outer electron decreases. Thus, the size radius of the atom increases. Example 2. Why is potassium bigger than sodium? The answer is the element sodium has the electron configuration 1s2, 2s2, 2p6, 3s1. The outer energy level is 3 and there is one valence electron. The attraction between this lone valence electron and the nucleus with 11 protons is shielded by the other 10 core electrons. The electron configuration for potassium is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. While there are more protons in potassium atom, there are also many more electrons shading the outer electron from the nucleus. The outmost electron for S1 therefore is held very loosely. Because of shading, the nucleus has less control over this 4s1 electron than it does over a s1 electron. Example 3. Explain the change in atomic radius from first, lithium to rubidium, second, natrium to argon. The answer is atomic radius increased from lithium to rubidium because of increasing off shell and increasing screening effect in rubidium. Attraction between nucleus and outer electron weaker, so the size is increases. The second answer is the atomic radius decreased from sodium to argon because proton number increased. Z effective increased. Attraction between nucleus and outer electron stronger, so the size is decreases.
Alright, let's move to example 4. Observe the graph diagram 1 below. Alright, there is a graph here. Take your time observing it. Alright, we need to know two things to answer this question. Is that the size of neutral atomic radius bigger than its cation, and size of neutral atomic radius smaller than its anion. So the question is, why the size of atom Na is bigger than its cation? So to answer this, sodium, the notation of sodium is 1s2, 2s2, 2p6, 3s1, and for notation for Na plus 1s2, 2s2, and 2p6. From this notation, we can see that Na plus is smaller than neutral Na. First, we need to write the notation for both neutral and the cation. Second, cation of Na plus is formed when an atom loses its valence electron. So we need to explain how Na plus is formed. Then neutral atom Na and cation. Na plus have same number of proton, but Na plus contains less electrons or less number of shell than its neutral atom. The fourth point is therefore, For Na+, the attractive forces between nucleus and remaining electrons is greater than in the neutral form. Thus, the size of cation is smaller than its neutral atom. Example 5. Why the size of atom Cl chlorine is smaller than the size of its anion? So first we need to write notation for both neutral Cl and anion chlorine. So for neutral chlorine, we will get 1s2, 2s2, 2p6, 3s2, 3p5. And for its anion, we will get 1s2, 2s2, 2p6, 3s2, and 3p6. So let's look at 3p5 at the neutral chlorine and 3p6 in its anion. So there will be difference at the at P. So the second point we need to write is how an ion is formed. An ion is formed when an atom accepts electron. We also need to compare that neutral atom Cl and cation chlorine Cl minus have same number of proton, but Cl contains more electrons than its neutral atom. So we have the comparison there. So therefore, for Cl minus, the mutual repulsion between the electrons increases. The fourth point is the repulsion causes the electron cloud spread out and the outer orbital expand. The conclusion, thus the size of an ion is larger than its neutral atom. Alright, let's move to exercise 1. Exercise 1 is element 11A, 12B, and 16C are found in periodic table. Which element has the largest atomic radius? Explain your answer. Alright, for this question, firstly we need to compare the atomic radius of an element and its corresponding ionic radius. And please take note that we need to exclude the comparison of radii for isoelectronic ions. And second, we need to add introduction of cation and anion, just like this. This is how we are going to answer this question. Right, let me enlarge the picture a little bit. And first, say that what is cation? Cation are formed when a neutral atom loses an electron. The alkali metals or group 1 lose a single electron to form a cation with a positive 1 charge. The alkaline earth metals or group 2 elements lose 2 electrons to form a 2+ charge or positive 2 charge. Aluminium, a member of the group 3, loses 3 electrons to form a 3+ charge. Right. See the example. Na or sodium will be Na plus electron, plus 1 electron, because it's from group 1. And aluminium from group 3 will be 3+ plus 3 electrons. Alright, let's see the anion. What is anion? Anion are atoms or radicals, groups of atoms that gain electrons, alright, consequently giving it negative charge. The number of electrons gained, so the charge of the ion. So for example, chlorine gains 1 electron to become Cl-1, while oxygen gains 2 electrons to become O2 negative. See the example, chlorine plus 1 electron will become Cl minus, oxygen. Alright, exercise 2. The question is, choose the larger particle in each pair. So we have Al or Al3 plus and S or S2 minus. So we do know that anion is bigger than neutral, cation is smaller than neutral. So the answer will be Al atom is larger than Al3 plus. So B, the answer will be S2 minus atom is larger than S atom. Alright, this is exercise 3. Define atomic radius and describe the periodic trend for atomic radius. So, for this question 1 Roman, we need to answer like this. The total distance from an atom's nucleus to the outermost orbital of electron. That's the definition of atomic radius. For the question 2 Roman, describe the periodic trend for atomic radius. Atomic radius decreases across a period and increases down a group. And the second point is, across a period, effective nuclear charge increases as electron shielding remain constant.